Hey guys, how's it going? Welcome to another episode of Ferris Makes Emulators. Big deep breath. We actually made it before Christmas. Mario Tennis is fixed. Let me show you guys this, because I know I've shown it with some hacks before how it should look, but it's still so satisfying to see this transition. You ready, guys? Goal. Oh, it's so satisfying, you guys. Oh, and I am so mad about how I found it. I'm so mad about it. Because this is not... Oh, is my system audio not working? Hold up. You guys should be getting audio for that. Okay, now it looks like it works. Anyway. So, for those, I want this to kind of be a somewhat quick stream, because I gotta pack and stuff before I leave. But I do really want to share this before I go, because I would love to get this on the stream, because I did end up fixing it off the stream, and that was totally unintentional. I'm sorry about that. I did not mean to fix it. That's the thing. So let me give you a little more backstory about what we did yesterday for those of you guys who weren't here. I did a huge push with all this serial stuff I've been building, thinking that this was still a CPU bug. I do think there are possibly CPU bugs still lurking, because some of the other games are still broken, particularly 2 of the 3 games that are still broken I know use bit string ops. In fact, I think all of them do. And I think that I really want to test those. I also would love to test the floating point stuff and exceptions. I mean, even if those don't fix games, I really want to get those covered with tests now that we have this framework. So I totally want to do that. But ended up spending yesterday doing a ton of these tests. And these have been running since then. Like, I think I started this. I don't remember if I started this at the end of the stream last night. But if I didn't, I did shortly after. So, like, these have been running since then. You can see this is iteration 1085 of running all 40 tests. I haven't restarted this. I haven't even touched this. And it has found no errors, right? Which is actually now really cool. It was less cool last night when before I fixed tennis. But I mean, all things considered, this is actually pretty sick. Because we can do a little math here. We know that it's about 1,000 instructions per test by 40 tests by 1,085 iterations. And we have run about 43.5 million randomly generated CPU instructions on the hardware and in the emulator with 0 errors. Now, there are certain classes of instructions that I still haven't tested yet, and I really want to get to those in the new year. But until then, we can just be really happy about this. So, with that in mind, I left the stream yesterday a little bit disappointed. I'm not going to lie, and you guys can probably tell. Because that was an almost 8-hour stream of just writing tests and writing tests, and not finding a single thing. So I let it run for a couple hours, and it must have been, I think I fixed the bug around 1 or 2 in the morning, because it just bothered me. It bothered me so much. But what I did is I didn't really look for the bug after that. I just kind of sat down just looking at the emulator code, and I just kind of thought, man, where could this bug be? And I started thinking, well, okay, if I can't work on this later anyway, but there are a couple parts of the code I want to clean up. Particularly, I went into the video hardware code. This is something I knew I wanted to do for a long time. And I just started renaming all the registers. These names come from a lot of both the official documentation, but a lot of other emulators use this as well. The only places I see that don't actually use these names for these registers is in the text scroll that we've seen before. And I don't know why they don't use these names, probably just because they were using more descriptive names, and I was kind of on board with that. But the more I looked at this and saw other emulator code, I thought it would make a lot of sense to match the names. Because, for example, if one of the other emulator authors wants to dig into this code and see how it works, this is going to be more clear. And I think that this is kind of a better, even though these names aren't as descriptive, it's better to communicate, XPCTRL is the register with a particular bit that helps. You know what I mean? So I just went through and changed all the register names. That was all I was doing, just to clean up the code. And as I was doing that, I was going through the official docs. Now, I can't show the official docs. I'm perfectly open about saying that I have them and that I look at them, because I think that's fine, but I can't distribute them because it's, that kind of thing. So I was looking through the official docs and I was just reading them pretty linearly just to get all the register names and put them in here. And as I was doing so, I passed a section in the official docs. Now this section, for those of you guys playing along at home, and just for the record, this section is 22.4, and it's called Interrupt Pending and Enable Flags Cleared on Reset. Now, I must have read this section several times. Because first of all, there is code that almost did the right thing in the emulator. So I must have read this. But essentially, there's three sort of reset conditions that pertain to the video hardware. The first one is hard reset, so when the thing is actually powered on. And so if we look at the initial state here, so particularly this pertains to these interrupt pending and interrupt enable registers. And you can see I changed to the more proper names here. And on startup, this is just the default state. They're all set to 0. So that's sort of the first reset case. That one's trivial, and we knew that this was correct. We knew that this was correct based on the hardware tests, and that's fine. There's another couple things you can do though, particularly with the display control and also the drawing control. There's a couple bits down here. If you look at DPCTRL, which is the display control, and then XPCTRL is the drawing control. When you set this, so here. Yeah, here it's writing the value. There's a particular bit, which is called DPRST, and there's also XPRST for the drawing one. And this is just a strobe bit, so this is the lowest bit of the register. And if you write 1 to this... wait, hold on, forget you saw that. I was supposed to git stash. Hold up. If we look at this... When you set DPRST, a couple of things happen. First of all, it basically disables the display state, so it sets that to idle. And then it goes in and it takes all these interrupt pending values, and it also sets them to false, these different flags. So these become true if some condition happens. For example, at the beginning of a game frame, or if the left frame buffer just finished displaying, or if the right frame buffer finished displaying, then these will be set to 1. Right? And then the thing is that this just sets the interrupt pending bits to false, right? So this means that the interrupt could happen again later. They could even happen again like the same cycle, or the next cycle or something. But basically it would set these to false. Now this is correct behavior, by the way. But what I didn't do correctly, and what it says very clearly in the documentation, is that it's not just the pending bits that get cleared, it's also the enable bits that gets cleared, right? So looking at this code, let me do a git stash, and then you'll see particularly the fix, and that's it, right? So instead of just setting these interrupt pending bits, you also have to set the interrupt enable bits. This actually makes perfect sense, because what Mario Tennis does is before it starts decompressing graphics, it writes to this display control register, and also the drawing control. I actually don't know if it's the display control or the drawing control that's the issue, but I think it's the display control, because I think it was the game start interrupt, or maybe it was frame start interrupt that was firing. I don't remember which one that caused the issue, but as it turns out, that interrupt that we were chasing down, it wasn't supposed to fire, but for completely different reasons than I thought. So yeah, so right before it does graphics decompression, it writes to this display control register with this reset bit set, and that reset bit actually disables the interrupts. That's the whole fix. And I found this on accident because I was just changing the register names to be more compatible with existing pieces of work, and just happened to pass a section of the docs that I must have read 100 times. And it's really frustrating because I actually think part of the reason I missed this was because I was using different register names. I was using descriptive semantic names rather than the actual names, because it's really easy to know that this is how it should work if you're reading a doc that mentions the register names. Another thing about this is that this is actually not mentioned in the text scroll. The fact that you do the pending bits is mentioned there, but the enable bits are not mentioned there. So that's another thing, is that it was frankly wrong, and it also mentions the wrong bits. And because that actually disagrees with which bits actually get cleared and the official docs, the test that I want to write today now that we fixed this, and there was one more change too in the drawing status, which is this one here, where it was doing the drawing process and pending bit, it would disable that, and then I also added the enable. It should disable this as well. There's another couple bits that this also disables that we don't cover here, but that's because we don't support those interrupts yet. So this is fine. But yeah, so that was the bug. That was the fix. And again, I found it just totally not even trying to fix the bug. I was just trying to clean up the code a bit and happened to pass that section in the docs with the context of this almost working emulator where this one thing was wrong. So I mean, like, I read through it and I looked at the code and I looked at that section and I went, no. And then I just changed it and it fixed it. So that's how I fixed it. And that's the entire difference. So the test I want to write is I want to write a simple hardware test, and all I want to do is set the interrupt enable bits here. I want to set them to the register. I want to read them back to make sure it matches what we sent. Then I want to set this control register with this reset bit set, and then I want to read the interrupt enable bits and see what they are. That's the whole test I want to do. And that should match. Oh, hey, Jacob Mishka. Yeah, it's been a while. Yeah, exactly, 8 little bits. And you can see how clearly it describes that, especially with the right register names. Yeah, thanks, man. So that's it. It's a trivial thing. It wasn't related to our CPU tests, which are still running, by the way. If you can see the Virtual Boy chugging on it, it's been running for a very long time now, which is awesome. But this testing framework will help us add regression tests for things like this, which I definitely think we need. And I definitely want to do a little bit more exploration with these kind of details of the video hardware too. Because we also still need to fix the other ROMs. This didn't fix any other game but this one. But geez, I think, so the first one, yeah, exactly, ZZYXX. No, it was, I can't remember the first one of these. Oh, I have dates. We can look at this. Let me check my, so for the streaming stuff, I save all my overlays and everything. So if I just look at those, I can find out which one we started with. Check my backup folder here. 13 is when I started doing this again. Wait, I need titles here. Fair stream stuff, episodes, emulators. So, because remember, I fixed this earlier, which was in like February, and then it turned out to just be that I got the same thing wrong that Minafin does. That doesn't actually fix it, but it ends up working. So if I look at this, assuming that we started on the first bug squashing episode, which that may not be correct, that was the 16th of March. So like 9 months. Now, granted, there were a couple months in there where I wasn't working on this project that much directly and whatnot. So, I mean, it is what it is. And we also did a lot of stuff in the process. Like, our video hardware timing is still the best in the game by far. Like, there are certain like intro sequences to games that other emulators don't even get close to running correctly, but ours totally does. So it wasn't for nothing. We did make a lot of progress during that time. It's just we didn't fix this one bug. And I don't know. I guess that's part of the game. Happens sometimes. But I'm definitely going to scour the manuals a little more when I'm on break to see if there's anything else I can find, because this was just a freebie. When you really think about it. But for example, this intro to Space Invaders is another example of like this intro sequence here. I don't think I've seen another emulator do this correctly, and ours just works. And that's pretty cool. Another one that if you guys remember we fixed when doing the video timing tests, there was the virtual bowling. And it's like one frame that's correct, that none of the other ones get right. Let me pull that up here. And we still get the sample playback rate wrong, but this little sequence here, there's a part where the ball hits the pins, It's here. And right there where they kind of explode, that frame usually shows a glitch frame and then the proper stuff. And we got that right too. So. Oh boy. But yeah, there it is. That's the bug. And yeah, super simple to fix. So I'm happy it's fixed. I'm very happy it's fixed. I'm a little bit embarrassed that this is what it was. Oh, hey, Peepercack. Nice to see you again, man. Hope you've been doing well. And I hope you've also been listening to a lot of Camellia. But yeah, it's fixed. This is awesome. So what I want to do again is just write a quick hardware test that proves this. Now to do that, I have to stop the CPU tests that are still running because we have to test this on the hardware. So I'll let it finish this current round or whatever round it's on. Round 1097. And then I can just, well, I'll actually shut it off before I go, but because we need to do more tests in this suite when I get back anyway, but yeah, I just thought it would be the coolest thing to close out the year by explaining that this was fixed, explaining how I fixed it, and also writing the test that proves that this is what it is. But I'm convinced. Like I don't think when we write the test we're gonna find any surprises because this is documented. It does fix the bug. It doesn't seem to break anything else. It makes perfect sense. And yeah, we got a lot of other stuff here. Like we got a lot of the testing environment stuff, which I'm super happy about because that'll help us track down the other bugs for sure. And I'm pretty stoked about this. I might also, since we have all the CI stuff set up, I might also push another version of Roaster Boy because I actually haven't realized it's been a super long time. First of all, since I updated the blog, and second of all, since we put out a binary release, and all I really have to do is just push to GitHub with a certain tag. So we can do like a 0.9 release at this point. That's okay. Still has some bugs and the UI still sucks, but yeah. Happy to hear that, Papercack. Yeah, the Norwegian environment's missing a fin as well, so. Oh yeah, that finished. But yeah, it should be pretty cool. Yeah, I might even get back to N64 in the new year. I still to be clear, my goal for this Virtual Boy emulator, I really want to get to 1.0. I really want to fix all the game compatibility. I really want to do the libretto front end. And I would really like to get to like a 1.0 release that I'm really happy with. But we're making progress, and I think with all this testing we'll definitely get there. So I just feel like such an idiot. But we can make this test now. So all I want to do is I don't want to do like proper regression testing stuff right now because I don't want to do any framework crap. I just want to do this stream to close out the year with us saying that yes, this is the problem. So I just want to go down here in our fuzzing stuff. And I had this thing, I think I just called it flat ROM, which ended up being like a hello from C test. If we go in here. Okay, I actually deleted the code that loaded it, but that's fine. We'll just go back to that, I guess. Or we can just add it here, which is even better. Or we can add it as one of the tests. Although it's not a fuzzing test, so we'll see what we need. But anyway, just sort of hack this on here. I probably won't get EverDrive. I'm going to get whatever Marshall's was. Again, I always forget the website, but it's a different N64 cart. But I will totally buy one of those, and I will totally get one with Serial, because I totally want to have this stuff set up for the next thing. It'll also be nice because it's MIPS, and that'll be a lot more widely supported by things, so might even be able to write test ROMs in Rust, which would be really cool. Because, yeah, I do want to get on that. I don't want to go as far with that project as we did with this one. But I really want to work on that at some point. Anyway, in the meantime, let's write this test. So this flat ROM thing was really simple. I think I still have this thing open here. And I actually want to set up loading for it first. So we'll do something like this. Use std. Oh, it's up here. Alphabetical order because I like it. CFS file. It's funny too because that hardware manual, I have it printed out too. Like I read through it from time to time. And I must have missed that so many times. And I do actually wonder if it was also down to the mental overhead of mapping the other register names, because it's so clear when they match. Yeah, that's how it goes. Anyway, I'll just hack this in here because I just want to get this test written down. So we'll even just call it flat ROM. And I'm actually going to look that up, yeah, because I keep mentioning it, and I think yes, 64 drive, that's the one. That's the one I'll end up getting. Because this was just, like, having the serial setup is just too valuable now that we've built it and I've seen how great it is. It's too valuable. I'm not going to do another emulator project without something like this. So yes, we'll do file is file open, and we can just hard code a path here, which will be this flat ROM build. I think it's called test ROM in there. Yeah, test ROM.vxe. Yeah, once you go serial, never go back, exactly. And yeah, like I think also the Super EverDrive also has a serial port that I haven't played with, but like that would be when I fix up the audio unit stuff, I might use that. Who knows? This, I think file dot read all bytes in mute buff dot unwrap. We need to unwrap this too. Actually, we can even do this. Was that not it? Read to end. That's what I wanted. Oh yeah, but I meant the Super EverDrive, the one I have for Super Nintendo. I think SD to SNES also has the port, but I don't know if it actually supports that. But I know the EverDrive does, but I never used it. Yeah, just way too helpful not to do something like that again. Because actually, like, building the protocol and stuff was not that hard. Just took a little bit of time to do it right, but then that's it. But yeah, so here what I want to do, I think we just do... We'll still do this. Always got to do fade, babe. It's my favorite. This will be in mute. This will be in mute. This will be flat ROM. And again, we'll make this a proper part of our test suite later, but I just want to get it codified today. I think that's all we need. Yeah, so it ran the flat ROM correct. You can see it said hello from C on the hardware, because that's what it does currently. And I think I'm also going to comment this out, just for now. We'll do one of these too. Just to be helpful here. Yep, so it looks like it was okay. And let's see, now we can change the ROM itself. So it's just written in really basic C. It even has all this printing stuff in it, so we can like print out the register values. So what I want to do is very simple. Print out hello from C. Doesn't hurt anything. And then test reg stuff. What do we want to do here? I think I may not have copied all the right registers either from the loader stuff. We'll just get what we need. So we want these, because these are the interrupt enable stuff. And actually we want let's grab these. Should be enough. I'm gonna skip a lot of these because we only need, actually we only need the control. We don't need the status. And then we don't really care about interrupt clear either, because we're going to clear it with the hardware. And don't really care about pending either in this case. We'll worry about pending interrupts later. And a couple of these flags I'm not going to check either, because I know we don't support them yet. Yeah, we actually really only care about these reset ones. And then here we don't need time error because we don't support that. SP hit we do, XPN we do. We support all these except we also don't support scan error. So these are the ones right here. So this should be really simple. Even add a to do. So we're gonna do VIP regs, and we do int enb. And we'll just do all the bits. This is not going to be the prettiest thing in the world, but it's gonna read okay. In fact, let's even do this. No worries. Thanks for joining, Jigamishka. Relevant bits. Do that. So then we can say interrupt enable is relevant bits. And then we want to do a couple things. I want to do, yeah, we want to read this first of all. Yes, we can do. And if this doesn't match, we can do return -1. That's how we'll do our error condition here. And then we'll do cleared the display bits via reset. So we're going to do vipregs and I think we want to do dpctrl. And I think I only want to do reset. And that kind of, let me see something. I don't know if we can read this. I'm going to check some docs. I mean, I can just set the bits that I know that we need to set. Let's just do that. So we'll actually get the rest of these too. I think we need to do one right where we do reset and another one where we enable everything again. Let's do that first. Let's just do dprst. Now this will like disable the display and stuff, so we need to be a little careful here. I think I'm also going to disable drawing before I disable display. And the last thing I'm going to do, we're going to re-enable everything just to make sure. We'll just copy the code from the loader that does this. Because reset will actually disable this hardware as far as I know too. Because it's like a forced reset. Okay, actually, by the way, oh, we don't care about this stuff. Actually, we'll wait for vblank. Yeah, let's just do all this again. And then we can print all these out. That's what I want to do here. And this should be all of them except these two. And this one's going to be if all the other bits, so if it's not 0. DPRST ones. They're going to return -1 there. I think that's all we need, and then we can return 0 on success. Last thing I need to do, though, for sure. Do this crap. Yeah, I think this makes sense. Let's just see what happens. Ah, whoops, we need to build the ROM. And we're missing some registers because I copied this code. So go ahead and steal those again. I'll just take all these. Or at least these ones. Or these ones. We don't need the version one. But see, like this stuff uses these same register names too. So it makes a lot more sense for us to conform to those. Yet more reasons to do that. So we got hello from C, and then stuff broke. Wonder why that is. The Virtual Boy got stuck somewhere. The downside of this is that this might be a bit finicky, but it shouldn't matter that we would raise interrupts because we should just return from them anyway. We could also do this piecewise. I think that'd be smart. Just test this one first. And here, it got covered up by stuff, but what happened to my printing? This used to be pretty. First I need to figure out why my printing got messed up. We'll get to the actual issue in a sec. Oh, I know what it is. These don't include new lines. That's an easy one to fix. Because then it'll make it really easy to see what didn't match. And I'm guessing it's going to be the return code, which is R10. I need to print register names here. This is so ugly right now, but it's it's fine. Oh, I don't have indices here. I can do this though. I think it's that. Then we need to do our this with the index. Otherwise, PSW. This doesn't need to be pretty, it just needs to work. I think that's R31. We may only get 30 back, but I think that makes sense. But yeah, so then we see R10 didn't match and R11, which is probably an intermediate, didn't match either. So this was hardware and this was the emulator. It's weird that this is 0. Although that could be a number of different things. The important thing is that this didn't match. So I'm most concerned about that. So we actually would like to... I'm actually going to add a small delay here. And actually we'll just call it the whole thing. Here. There's STD time duration from millis. Something like that. Because I want to see what it says in the emulator for what the value for this is. So it ends up being all zeros. It ends up getting like clobbered by the loader too. I'm surprised about that. Also, 1 second here, because I may have done this wrong. I think these are not supposed to... Yeah, these are U16s. Technically, I should be using U16s here. Even though U32s should work, because it looks like they work on the hardware. Let's just see if that changes it. If it does, I actually want to fix that. That's still 0 on the hardware. Or on the emulator. Rohalov, thanks for follow. 601E is what we get on the other one. Just to look at what these are. This would be our E. Yeah, 601E. So yeah, that actually matches exactly what we expected on the hardware. Yet somehow we're getting it wrong when we're reading this back from Rushto Boy. That's a bit weird, isn't it? Because it should just be those six bits here. I got so many tabs open here. I'm just gonna close all these. It should just be these 6 here that we support, and those are the ones that we set here. So interrupt enable should set all these. Did I not do reads for the interrupt enables? That can't be right. No, here they are. And this should only do half words. Because like a word write, like a U32 write, should be just doing that and then the next one. So that should have worked. Not sure why it didn't. That is odd. Just to make sure I'm using this correctly. That is what this does. That's very odd that it just doesn't get the right value. It shouldn't be doing these as byte writes and byte reads. That doesn't make sense. Besides, this should actually work out anyway, due to the way that we're doing that. No, I wanted to look at the write. So the write should print out the value when we set the interrupt enable. Let me enable this logging actually. And I think the way we do that now is this log core VIP. But yeah, it looks like the R11 is the temp variable that it uses for this too. There's so much printing that the VIP does. Maybe we're not going to see it here. I can comment out a lot of the printing too if we have to. Just to see that this is correct. Yeah, I'm going to do that. I think this will just be easier. Thanks, Mr. Liquid. Maybe less is easier. I just don't know how to use less. Okay, here we go. It's actually at the top here. This is good enough. So these are the initial values. And it never seems to set those before it reads them. That's a bit odd, isn't it? These also were writing half words. Must be something wrong with the ROM because this definitely works. Otherwise, a lot of the games would be a lot more broken. That's super strange. Especially because we see it print the value. I mean, we could even just grep it. So, for example, not sure how that didn't work. So there we get DPCTRL, which is what we should get. But it's weird because it reads the value. I mean, it writes the value, so it gets here. It does this. So why didn't this happen? Doesn't seem like it is. This. So that should be the correct address. 5F802. As we can see here in our test ROM, 5F8, and then we index it with this one, and because it's a U16 pointer that we index, that should be 5F802. It's weird too, because the loader also, well, it at least writes to interrupt clear. Which this should also have printed. Oh, okay, that actually did. So that did go through, but somehow interrupt enable didn't. That's very odd. This is not the kind of thing I expected to deal with right now. It would make sense if it didn't actually do the write, because we're not seeing that in the emulator. We are seeing it on the hardware, though, so it would seem that the code would be correct. Does the read correctly. Very strange. I'm just going to see if this is any different. No, it's no different. It's so weird because it works on the hardware. That's so weird. For example, if we just don't do this and just start running the other bits of the test. Let's just see how far it gets. There it didn't get any farther in the test. That's somewhat interesting, actually. Oh yeah, it didn't rebuild the test ROM. The news blown bears that tennis works, and now we're writing a test to make sure that we got that right. Hold on, I need to... Yeah, it's actually gonna be Christmas. I think we're also getting somewhat wrong values here too. At least different than I expected. If we add this back in here. The hardware dispatch fails too. I wonder if it's stuck somewhere. Wouldn't expect it to be. Oh. What? I don't know if this just got a stale ROM or something. Hey, Sherlock. We're writing a hardware test for a bug that I just fixed in my Virtual Boy emulator. Not going to go into too much detail other than that because I want to focus on fixing this, but focus on fixing this test at least. BD6. So this is interesting that we got this 601E, correct? Oh, this is actually matching again. Yeah, the ROM is being built correctly. I think we just actually got like a bad cache on the ROM. And I wonder actually if this just mismatches because of something else, like another bit that we don't have. Because if you look at this, this actually matches like the 601E here, which is the value that we expected. Just somewhat interesting. I am going to do one more thing here because I did want to write this again, and then we'll make this ROM. I wonder if we were just executing a stale ROM or something weird. Yeah, because now they both fail, but they match except for this R12, which is just some temp register. Yeah, I'll go over it again once we get this test working. It'll be easier for me to describe once I'm not trying to fix this issue. But okay, this seems to match now, which is good enough for me. But it seems like both the hardware and this actually don't get the correct bits here. But let's do this though, just to make sure we're not getting any other crap. Thanks for the follow, Sherlock. Let's go ahead and do this when we read this out, because that'll be helpful. We should mask out the bits we don't care about. Cool, Sherlock. Yeah, I'll be happy to explain this again when this works. Oops, forgot to build again. Yeah, that bug was that basic. So now I actually wonder if we do this grep again, if we get those. It still doesn't. Now I wonder if it's just not writing that. That's so weird because we should be seeing when it reads and writes from this, because the emulator's definitely gonna print. What the hell is going wrong here? That's actually really annoying. Oh, wait. I have this misspelled, don't I? At least there I do. The rights should still come through, though. So this will probably print on the reads. And somehow not the rights. I wonder if that's just not working the way that I wrote it. Still nothing. What the hell? Naturally, I'm not that thrilled about this going wrong right now. No, I'm not trying to reintroduce the bug. I'm trying to codify a regression test for the bug. Is what I'm doing here. And somehow this isn't working out. I'm not really sure why. It seemed to work better if I just wrote this. Which I'll be happy enough with, I guess. The emulator is written in Rust. The test code is C. Yeah, they're on YouTube. You can find my links down below. I appreciate the excitement, by the way. Sorry I'm not being as descriptive as I usually am. It's so weird. See, we get the interrupt pending ones. We also get interrupt clear. And somehow we're not getting the other ones. All right, we're going to do this. Seriously? Can't symbol for architecture unknown? This is the same architecture we've been using this whole time. I think it was MV810. Gotta go in my history here. Because the ELF file should have this. Oh yeah, of course. OBJ dump. We need the V810 one. So I want to see main. Here's main. No, not all 57 are fixing one bug. Yeah, it's kind of a mountain of stuff to consume. Yeah, files are appropriate. So I don't know why this is being weird. Let me just try and isolate this in main here. Just try and isolate this one right. This one. And it optimizes it. Of course it does. Oh, right, because I didn't do the actual write. So here it looks like it loads some base address into R10 because this probably stores the variable here. Yeah, so R11 is going to be the address of the VIP register here. I'm guessing that's what 24606 is. I'll just look at that in the thing here. I really need to fix this because I gotta go to the US tomorrow. 601E plus 2 seems a bit wrong. Oh no, this 601E is our value. That's what that is. And then this is probably loading into R10 the base offset of this. So then storing a half word from R11, which is 601E, which is the correct value, into R10 offset by 2 should be storing that register. That should be correct. Yeah, it was a really dumb bug, Dark Second. And I found it when cleaning the code as the CPU tests were running. Okay, something's up with the hardware here. Why doesn't this work? Now I'm having a frustrating experience. Also gonna do this, by the way, because I want to see the dump for this. And it should be the same, yeah. That's what I would expect. What an unsatisfying way to end the year. And by having none of the tests work. Why is the hardware being fussy now? That's what I don't understand. This has not been an issue. What the hell? So protocol violation usually means that it didn't run correctly or it failed to send everything or something stupid like that. This is so weird, you guys. Yeah, I'm gonna run this just with the full suite right now to see if that works. Then I'll reset the teensy if that doesn't. Because I've never had to reset the teensy either. Except maybe a couple times. That was when I was actually like having issues with the software on there. Yeah, so this is fine. So something's up with this ROM. Honestly, though, if I can't get this working right now, then I'll just say screw it, because I did not plan for this to be a very long stream today. I just wanted to show you guys that it worked and then make this test. If it continues to cause us grief, then I'm just going to say screw it, because this is not how I want to spend my last evening, is chasing this down. It's kind of funny, though. I'm definitely seeing the humor. Just a little bit frustrated about it. Does it get stuck somewhere? It's so strange. Because if we do this, for example, if we do nothing in this test ROM, right? So our main is just move 0 to R10 because this is our return 0. And then that breaks. Oh no, then it worked, right? It worked and then it just sat there delaying, which is okay. Right, so that's fine. Maybe I'm just not, maybe this was actually working and I just didn't realize. No, because we did get the hardware dispatch failed. So okay, so that's fine. So then we do this and it just enables the interrupts. Maybe that's it. Maybe the interrupts are causing issues. So here, we set all that up. Okay, so it doesn't like the interrupts. Is probably what's going on because this is actually enabling those. If we do, for example, int clear, and we go ahead and make this, and we do this, we should see almost the same code in main, except this uses 4 instead of 2 as an offset. And then if this works, then it's something about the interrupts running that causes it to fail. Yeah, that works. So it doesn't like that it's running interrupts. It shouldn't be a problem because we did set this up. Ah, wait a minute. It's probably the alignment crap that we hit yesterday, isn't it? I actually bet that's what that is. So let's just print out the assembler stuff. Actually, I wanted the, is it relocations that I wanted? I can't remember which flag I want here. Oh, let's do the whole contents. No, we want the, we want disassemble all. Unless this test ROM just doesn't have vectors for this. Oh, God. Oh, no, wait, because it's not, this shouldn't have those. It's the loader should have them, and we are pretty certain that that was correct. I'm getting visibly flustered. So if we look at VIP, this should just return E40. And this returning shouldn't cause us any issues. Unlike divide by 0, which excuse me, divide by 0, which causes an exception in the middle of the instruction. So then we had to adjust the EIPC so that we could jump back correctly. The VIP should be doing fine here. Let me do another obj dump of the loader, which, yeah, VIP should be at E40. That should just return. Although, you know what? I actually think this is. Okay. Our setup will actually not work for doing this test yet. I'm going to call it now. Because here's what I think is happening. We enable the interrupts, and then what happens is this interrupt fires, and then it probably returns, and then it probably fires again immediately after that. Because we never acknowledge the interrupt by doing int clear. That's probably what this is. And I don't want to just hack that in the loader because I want to do these tests a little more properly now that we've got everything working. And it needs to at least preserve registers, and like we don't even have a proper stack pointer. Well, actually, that should work. But anyway, I would like to be able to edit the loader so that we can actually inject our own handlers. So that, for example, this test would then, first it would inject an interrupt handler that would just do nothing. And then it would, yeah, do that stuff. So I'm guessing it's that we need to set int clear with int pending during this interrupt. So yeah, I'm going to call it here, and we'll do the test later. But I think this is worth a shot, and I'll definitely know to do that when I get back. But anyway, once again, the issue here... was very simple. 8 little bits. The thing is that we need to clear it within the interrupt handler. So we can't just clear it first unless we get lucky, because an interrupt might actually happen between those. So I don't want to just do that. But I'm calling it. We're not going to finish this. I'm going to end this stream for now. Just by showing the fact that Mario Tennis does actually work in the emulator now. And then I can, for those of you guys that joined in the middle, I can explain it one more time. But we'll just end with this, the fact that it works. So the bug was that between, like, transitioning after this screen, it would fade back in and all the graphics would be corrupted. And the issue was that during the graphics decompression, an interrupt would fire that wouldn't preserve all the registers. So it would clobber some of the registers that the graphics decompression routine was using, and then it would just make completely bogus data. So that was the issue. And to fix it, it was actually really easy. We just, there's a particular reset bit in the VIP registers, a couple of these. And when those are set, this actually needs to not only disable the fact that interrupts are pending for certain interrupts, but it also needs to disable interrupts, these interrupt enable bits, which is the detail that I got wrong in the emulator beforehand. It was really easy to fix. I ended up finding that just when trying to clean up some code and change some register names, which led me to read through some official docs that had a very clear section about how this should work. And somehow I missed that. But in the meantime, we did spend a lot of time, at least a lot of time on the streams. You got to remember, the stream is about 2 hours long, and there were several months where I wasn't working on this at all off of the stream. So let's say we spent like 30 episodes on this, and then 30 by 2 hours is only 60 hours, right? So that's a couple days, which is not too bad for a bug that we just didn't know where to look. And in the meantime, we were able to build this really cool serial test frameworks. Like, I'm just able to just send code over a lot easier than I was with just the flash card alone. So we built all that. That's awesome. We also made our video hardware timing a lot better than any other emulator that I know of right now. So that's really cool. And yeah. So I'm actually pretty happy with this. But yeah, for now I'm not going to add tests for this because we need to adjust the harness so that we can have the test ROMs be able to inject their own handlers for different interrupts. And right now I'm just not going to deal with that because this was not supposed to be a long stream. I just wanted to close out the year by explaining what happened and then adding a test. But we'll do the test later. So how far from perfect are we now? 3 of the games still don't work. I think 2 are basically unplayable. And there's some bugs that I'm really not happy with in some other ones. And that's the known bugs. So I want to do full test coverage of the floating point ops because I did a lot of test coverage on a lot of the CPU stuff and ran the CPU tests overnight, and they did really well. Didn't find a single error within a few tens of millions of instructions. I think like 40 million instructions that were randomly generated, and it ran them fine. But I still haven't tested the bit string ops. I still haven't tested the floating point ops. So I would really like to get some fuzzing tests on those as well. I suspect the bit string ones may have some issues with bounds that might cause some of the other bugs. And then we got to do some more searching. But with this test setup, this should be a lot easier. So I'm also going to do some tests where... like I want to fuzz the video hardware, so I want to set up the video hardware registers, like all the world specifiers in the object memory. I just want to give it a ton of random data and just see what it draws, and then test that against the emulator just to test like completely bogus and out of range values, because we have the right stuff to do that with. So it's pretty cool. And yeah, a lot of transfers without error, which I was actually a bit surprised about. I kind of expected something to be intermittently broken, but it seems like things are pretty stable. But yeah, I'm fairly certain the reason why this test ROM is failing is because it's just going into an infinite loop when it raises the VIP interrupts, which is understandable. And if we can inject our own handler into that, yeah. I know how I want to fix it. I just don't want to do it now. But yeah, so there's a lot of that kind of stuff that I still want to test before we're perfect. And even then, one of the things that will probably never get perfect is bus timing. Because I'm not really sure how to test that without doing a proper hardware rig. It might be that we can use the internal timer to do some stuff. I also want to go pretty hard on the timer and test some more stuff with that, if we can. But yeah, I mean, generally, I'm fairly satisfied. I mean, in the previous year, we've built this emulator from scratch. That's another thing, is that, you know, even though it feels like we spent a lot of time on that one bug, we were really spending a lot of time doing testing, and doing some reverse engineering as well. And the emulator got a lot better along the way, and it exists, and it's a pretty good one. So I'm actually pretty happy with this. I think I started this, yeah, almost exactly a year ago. So pretty cool stuff. So yeah, I'm still in the new year. I think the 11th would be the first day I would be able to stream, and I think I'm going to then. We'll continue with some of this testing stuff. We'll add more CPU tests. We'll do the video hardware fuzzing tests, just all that kind of stuff to try and get those details right. Do some timer tests. And just in doing that, we'll see if we can fix some bugs along the way, because I just want to fill out the tests, because then we can even make these into regression tests that we run on CI. Once we fixed all the games, or all the bugs in the games that we know about, then I want to focus a bit on the top level stuff. I've done basically no effort in terms of the user interface. A buddy of mine did some support for libretro, and I really want to make that the primary front end so we can kind of defer that problem and just work on having the core. If I can get that really good, I would really like to push for having Virtual Boy be the primary libretro core for Virtual Boy, because it's going to be a safer core, and it's going to be more accurate at that point, I think, than the other emulators, because I've seen some crazy bugs from doing all this that we just don't have in our emulator, even though we do have some bugs of our own. So I'd really like to make that kind of push. So I think there's still a good few months to work on this. But I'm really excited to do that. And I think also at some point I would really like to do a dynamic recompiler for the CPU for this. I think this is like the perfect kind of project to do that with, because now we have a really good CPU testing rig. And then we're going to have a lot more tests by the time we do that. And it's also a system where the bus timing is not going to be terribly important in terms of correctness. Like no games are going to be abusing stuff like that. And so I think when things are correct enough that we can run all the titles, that's kind of what we want to focus on. And even then, if those timings are something that we can reliably measure, then I still think we could do a proper recompiler core that would still do proper timing. Because really we'll be removing dispatch overhead. And because this is a 20 megahertz CPU that we're emulating, that actually would be significant. So, and I also want to do some more performance enhancements that are guided by profiling. So, but even though we didn't get this test ROM working today, there's a fairly clear path forward, and I'm super satisfied that this bug is fixed. But yeah, considering again that this is the last stream of the year, thanks guys again for joining me. I'm gonna head off. I think this has been really cool. Also, like the whole streaming thing in general has gone really well for me in the last year, I think, and well for us as a small community, if you want to even call it that. So super happy to see you guys that are regulars. You know, Blambear, Dark Second, Desu Dano Collin, Pyro ESP, all you guys that are here all the time. Michael McMillan more recently. And a bunch of other guys like Daru and some other guys that are here all the time. Thank you guys so much for hanging out. This is really, really fun. Yeah, not on this kind of hardware Desu, I think, but yeah, we'll see. But yeah, again, this has been really cool. Really cool journey, and I think this will still be cool in the new year. we've got a lot of really exciting things to work on with this project and many other projects. So again, thank you guys so much. This has been really cool. And happy holidays and all that stuff. I don't really know what else to say. I'm just very, very happy. So I guess I'll say it one more time. Thanks again, guys, and I will see you next year.